Okay. So carbon dioxide is formed between carbon and oxygen. And don't forget that the number in the bracket will now be the valency of carbon in this case, which is 4. Oxygen is still 2. 4 goes to oxygen, 2 goes to carbon. So that will now give us C2O4. Then you now reduce to the lowest term. So that will give us CO2. Carbon dioxide, CO2. Carbon dioxide, CO2. Then another one, now I want to look at the difference between the formula of carbon dioxide and carbon 2 oxide based on this system. Carbon 2 oxide. Still between carbon and oxygen. Carbon in this case now, instead of 4, the valency will be 2. Oxygen is 2 normally. So 2 goes to oxygen, 2 goes to carbon. So that will now be what? C2O2. So when you reduce that to the lowest term, carbon 2 oxide, which is called carbon monoxide, including this CO. And what you should know about this carbon monoxide is that it is the gas that is causing a major problem in the world now. That is causing greenhouse effect while we are having it everywhere. So it's carbon 2 oxide, it's a pollutant, a major pollutant. So carbon 2 oxide CO2 and carbon 4 oxide carbon 2 oxide CO, carbon 4 oxide CO2. So then you can move forward. You can move forward to look at another way, a compound. Another way of writing the compound. So I'm now moving from the simple to the complex one, where we are going to combine the knowledge of the periodic table with knowledge of some ions. Like we talk about ions. Ions are carrier of charges. Carrier of charges. They are group of elements possessing electric charges. Group of elements possessing electric charges. And we have some examples. Let's see. Hydroxide. Hydroxide is a negative ion because it is divided into 2. Let's look at the division. Ions are divided into 2. You have the cations and the anions. Cations and the anions. The cations are the positively charged ion. Positively charged. While the anion are the negatively charged ion. You see the way they combine it to also form a very, very more expansive compound. Negatively charged. And the major cation we have at your level that is more than one element is ammonium. Ammonium ion. Ammonium ion, which is what? NH4 plus. NH4 plus. Showing that it's a positively charged ion. The anions are many. You have the hydroxide ion, which is OH minus. You have the tetrasulfate 6 ion, sulfate 6, which is what? SO4 2 minus. You have the triazonitrate 5 ion, triazonitrate 5 ion, which is NO3 minus. That single minus or double minus is showing that the valency of hydroxide is 1. Because you don't need to come to this way to look at the valency. We only need this one for the periodic table. But this one you learn them from the charge, the valency and the charge, the strength of the charge, each of them is carrying. So for hydroxide the valency is 1. For the SO4 tetrasulfate valency is 2. For triazonitrate valency is 1. For triazocarbonate 4. Carbonate 4 ion. The valency is also 2, CO3 2 minus. For triazosulfate 4 trisulfide 4 sulfate. That is SO3 2 minus. The valence is 2, and so on and so forth. So let's say you have to write the formula of 1 sodium tetrasulfide 6 tetrasulfide 6 in any exam, or you need the formula to carry out a calculation or analysis, chemical analysis. That is the correct formula of sodium tetrasulfide 6 will be formed between normal sodium that we know from our previous classes to the one you are learning now. Tetrasulfide 6 is SO4. So it will be formed between Na and SO4. SO4 as a group, not as a splinter element. Is that okay? Sodium is 1 from the periodic table. SO4 is 2 from the valency, from the number of charges it is carrying. So at the end of the day, 2 for SO4 will go to sodium, 1 for sodium will go to SO4. So we now have that to be Na2 SO4. That is the correct formula of sodium tetrasulfide. So if the correct formula is not written, probably you will not put this through here at your head, because after this one now, when you get to the calculation part of it, you will understand what you are talking about. Probably you. So let's look at another example. We have aluminium triosocarbonate 4. Aluminium triosocarbonate 4. Osocarbonate 4. So that will be formed between aluminium and CO3. Triosocarbonate 4 is CO3. So the valence of aluminium from the periodic table is 3. CO3 triosocarbonate 4 is 2. From the number of charges it is carrying. So by the time they combine, they exchange their valency. 3 go to CO3, 2 go to aluminium, become Al2, CO3, 3. You have to be very careful here, because we are having a valency that will come here, and we are having compound element here. You have to put that compound in a bracket so as not to create a confusion with this 3 that is coming here. And apart from that, when you are doing your calculation, know that this 3 will only affect all the elements in the bracket and not aluminium. I believe that is clear. So aluminium triosocarbonate 4 is Al2 CO3 3. Let's take an example of the calculation that will affect that, so that you will appreciate the importance of writing the correct formula. Say, calculate the relative molecular mass. Relative. This is a common question in JAM, Y, NECO, NAPTEP, and others. Relative molecular mass of let's say I want to do some example that we okay, let's say magnesium triosonitrate 5. Magnesium triosonitrate 5. You say magnesium, the value will be given to the exam. In JAM, they don't normally give any value again, because they believe that a student who must have learned this thing from SS1 to SS3, Tech 1 to Tech 3, should have mastered the relative atomic masses. So magnesium is 24. Magnesium is 24. Triosonitrate 5, don't forget that NO3.